Hello, everybody. Today is an exciting day because we are starting our next unit, Unit 4, linear equations. And really the focus for Unit 4 is going to be all about graphs. So we just spent a unit talking about all the different types of representations. We have everything from tables to mappings to ordered pairs to functions. But this particular unit is going to focus on the equations and the graphing aspect. So we are going to start today with target 4B, which is going to be all about graphing linear inequality or linear equations, excuse me. So before we get going, all I really want you to do right now is pause your video and I want you to write down a couple things, maybe like write down really anything that you possibly could remember about lines. Go. Okay, graphing lines. We're going to see in just a moment how what you remember and if any of that kind of carries through to this year. So first and foremost, we do have to talk about a little bit of vocabulary before we kind of get into the nitty-gritty part of graphing. So the first thing that we're going to talk about is what does it mean to be something called an x-intercept or a y-intercept? These are pretty specific places on the graph. Now, something to kind of keep note of, whenever we talk about this piece called the graph of, and when we say the graph, and I'll write that on here, the graph, it really just means, just so you guys know, it means the line that is graphed. All right, because in a minute you're going to see that we're going to actually, all of these equations that we're going to graph are going to be completely straight lines. And we're going to talk about why that is in just a little bit. But we usually talk about where the graph crosses this, and I just realized I spelled that wrong. Not crosses, but just, you guys know the deal. But where the graph basically crosses a specific place. Now, on our graphs, we talked about the fact that we have an x-axis and a y-axis. And the nice thing is that if we call something an x-intercept, intercept is kind of another word for intersection. So if I'm talking about specifically an x-intercept, I'm talking about the point where the graph crosses the x-axis specifically. So where on that horizontal x-axis is my line going to cross it? And because of that fact, it's going to be a point. To get to any point on the x-axis, we're going to go left and right a certain amount, either positive to the right or negative to the left. And the key is, if it's on the x-axis, you're just not moving up or down at all. The y-axis is the opposite. This is the point where the graph crosses the y-axis. And really the opposite is true. Whatever point that is, we're definitely moving left or right 0 in order to stay on the y-axis, because the y-axis, I don't move left or right, but I can move up or down a certain amount. So we know kind of what the ordered pair is going to be looking like. Now, when it comes to graphing, just so you guys are aware, we talk about something called zeros. Zeros are really just another name for intercepts. And it really actually zeros, the term zeros is all inclusive. It means it's for both x and y. So a question I can ask you later on in this unit, I could actually say find the zeros. And that's really just a fancy way for saying tell me the x-intercepts and tell me the y-intercepts, okay? So let's actually get into the graphing aspect for today. Now, when we're gonna start graphing linear equations, we're gonna start by creating a table. Now, there are other ways that we can go about graphing equations, and some of those ways you guys already know, but we're gonna start with the most basic way of graphing functions out there, and that is to make a table. Now, unlike last unit, where you guys will probably notice that no matter what representation I gave you, whether it be table, line, graph, mapping, ordered pairs, I gave you the domain and the range. You're going to notice here that you're saying, well, Ms. Hardy, there are no points graphed. There's nothing in my table. The only thing that they're giving me is the function. So we have our f function, and it tells me we're going to do 3x minus 6. So I really want you to think about what that means. That simply means that every x value that we choose to plug in, we're going to multiply by 3 and then subtract 6. So here's the cool part about graphing. If we have a function like this, your domain is unlimited. You can pick any x value in the world that you want to plug in and see what we get out. So that's exactly what we're going to do. Now for this first graph, I'm going to start with probably the standard 5 points. In any graphing world, you always want to, there's always a good kind of range of points. These are not always the ones you want to use, but for today, we're going to start with these. Obviously, we always want to know what's happening at 0. That's the middle of our graph down here. I want to know if I'm going to go up or down from there. And this point specifically is also important because that also is an intercept. When x is 0, whatever y turns out to be, this is going to end up being my y-intercept. Okay. X-intercept, I don't know what that one is yet, but we'll hopefully find it. We'll see. So, and I'm going to pick 2 points on either side. So I'm going to pick 2 x values that come before it and 2 x values that come after it. Could you pick decimals? Sure. Could you pick 2.5 to plug that in afterwards? Yeah, you really want to, for sure. But the key is with all of these points, my goal is going to be to take each of those x values and we're going to evaluate it. So for example, my first one, I'm going to take f of x. I'm going to take f of whatever x is. And my goal is going to be to basically do this with every single one. I'm going to go through and every place that we have, I'm going to take whatever value we're plugging in and we're going to do it for each of the values in our table. So for example, this first one, I'm going to start by working with my first point. And I'm going to say, okay, well, when x is -2, what is y going to turn out to be? Well, we have to plug that in and actually see what's going to happen. So in place of that x, I'm going to plug in -2. And our goal is going to be to plug this in and simplify. So really what now my goal is I really want to go through now and I want to simplify this side of the equation. I want to know what 3 times -2 minus 6 is going to be. So let's go to our handy dandy trusty calculator and we're going to type it in and we're going to see. So I'm going to take my 3 times my -2 and I'm going to subtract 6. And we are going to get -12. So what that tells me is that in the place of y, we're going to have, ooh, that was exciting. We're going to have -12 as my answer. Now, you guys are going to notice that whenever we start graphing things, sometimes we sometimes find points that aren't the nicest to graph. And this is actually a good rule of thumb for this. When we plugged in -2, we got 12. But if I'm going to go down and put that on my graph down here, I'm going to go left. Obviously, I'm going to go left 2. And then I'm going to go down 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 is a little bit further down. And that's okay. If I go left 2, down 12, this point just goes off my grid a little bit. And we're going to keep going along the line. I'm going to take my next point. I'm going to plug in -1 because I want to see what happens when x is -1. What does y end up being? Well, 3 times -1 ends up being -3. Minus 6 ends up being -9. And you just found your next point. -1, -9 is the next point that we're going to go ahead and graph. And let's go do it. If I go left 1, I'm going to go down 9, and that point is right here. And keep going. F of 0, that's the next one that I'm going to plug in. 3 times 0 is 0, minus 6 is -6. And so I'm going to go left or right 0, down 6. What you guys just found, that point right there is your y-intercept. That's the place where we cross the y-axis. Okay. So if you guys look, ooh, that was exciting. One sec. Other than that, though, yeah, we're going to keep going. Plug in 1. 3 times 1 is 3. Minus 6 ends up being a -3. And hopefully you guys are starting to notice that there's a little bit of a trend in that each of my points, hopefully you're noticing to get to the next point, all we're really doing is subtracting 3. So if you choose x values that go in a row, your y values should always have a pattern to them. And there's a reason for this. We'll get there in just a moment. But last but not least, I'm going to plug into 3 times 2 is 6 minus 6 is going to end up being 0. So my last point that we have is 2, 0. And here's the cool thing about this one. That point is directly on my x-axis, which means we just found our x-intercept as well. And now, in terms of graphing, when it comes to tables, usually I'm only going to ask you to find 5 different points. Ideally, they're points that you want to graph, but at the end of the day comes the most important aspect. And that is right now, you haven't actually graphed this line completely because we've only chosen 5 points. Like, could I have chosen to plug in 1.5 up here? Sure. Could I have chosen to do negative 1.275? Sure. Because the domain on all of these is infinite. We can choose any x value in the world and we can plug this in. Now, does that mean it's always something we want to graph? No. Like, for example, if I plug in 100, could I solve that? Yeah. I could do 3 times 100, which is 300. Subtract 6 from that, and I can get 294. But is it really nice to graph the point 100, 294? No, because I'd have to go right 100 and up 294, and it's somewhere way off my grid. So in terms of graphing points, though, my point is that we only graphed 5 of the potentially infinite number of points. We didn't actually plug in anything in between each of the different ones that we picked. So to represent all of the points that we did not pick, what we do is we connect the dots and we draw arrows. We connect the dots to show all of the points that we didn't end up picking. And the arrows represent that this line goes on forever. So we could really choose any other points on this line, and those would actually be solutions to this. Now, we're humans, so we can't possibly do this forever, right? Like, we did 5 points, and think about how long that just took. But when we talk about graphing, at the end of the day, your graph should all look something like this. You don't necessarily always need to identify the x and the y-intercepts, but you must connect your dots, and you must draw arrows. If you're missing either one of those parts, you're missing part of this function. You haven't technically then graphed all the points on the line. You've only graphed the 5 points that you picked and plugged in, okay? So that is something we want to be really careful with. Now, for the second part, if you guys notice, it says, what are the intercepts? You just found them. To find, if you want to list them out though, my x-intercepts are going to be, I'm going to list the ordered pair. So we found that right here. This guy right here, that was when we plugged in 2 and moved up or down 0. So my x-intercept is 2, 0. And my y-intercept is going to be right there. I went left or right 0, and I went down 6. There are my intercepts. So what I want you guys to do right now, I want you guys to pause your video, and I want you to try part B on your own right now. Okay, your table should look something like this if you use the same values. If you chose to choose some different x values, that's totally fine as well. The cool part is that no matter which x values you choose, all of your points really should fall in a straight line. And it has something to do with what we're going to talk about a little bit more tomorrow, or at least in our next video. So when it comes to graphing though, your points, if you have a point that ends up kind of being out of skew, it doesn't follow the pattern, that probably means you plugged it in incorrectly. So your line, you should have had those as your points: -2 up 9, left 1 up 7, left to right 0 up 5, right 1 up 3, and right 2 up 1. So part B says, what are the intercepts? So for these, I waited for just a second because one of your intercepts shows up in your table. Whenever x ends up being 0, whatever the y-coordinate is, that ends up being your y-intercept. Because that's the point right there on the graph where you actually physically end up crossing your y-axis. So the y-intercept, I don't have to do a whole lot of work for. X-intercept, on the other hand, here we got to zoom in just a little bit because my x-intercept doesn't show up in my table. I don't see it on this side. There's no place in this x column or the y column where the y value is 0. That's what we look for in terms of x-intercepts. So in terms of the graph, you can kind of view where it is on the graph. Where I cross the x-axis appears to be kind of somewhere in there. Now, it just means for our purposes, it doesn't actually physically cross at a nice place. Now, can you find it? Sure. If I go back up to my table, you can use your equation kind of the reverse way. If I want to know when my y value is 0, well, let's just go back into our equation and let's plug it in. If I want to know when y is 0, all you have to do is plug it back in and solve. So I would start by subtracting 5 over to this side. We're going to get -5 is equal to -2x. If I divide by -2, x is going to turn out to be 2.5. And that right there is going to end up being your x-intercept. So if you ever don't know exactly where it is, you can always find it. You might have to plug another value into your table, but for linear equations, just so you guys know, you'll always have at least one of these. Okay. Now I say at least one. We are going to talk about, there is another way of kind of going about graphing. And the cool part is using just that idea of intercepts. And that's because to graph a line, really you need, like if we look up above, if all I did was graph, for example, like one of these points, that doesn't tell you kind of the trend of where all the other points are. But as soon as you graph the second point or a second point, you guys will notice that you only need 2 points to graph a line. So some people use that idea of x and y intercepts. They say, okay, well, I don't need 5, 10, 15 points. If I just find my intercepts, then those are the only 2 points you need to graph the line, connect and draw your arrows. So that's exactly what we're gonna do. To start, I'm gonna find my y-intercept because that's pretty nice. That's all I have to do is plug in x and then solve for y. So let's do that. If I go over to my equation, I'm going to take -2 times 0 minus 10. And let's simplify. -2 times 0 ends up being 0. Minus 10 ends up being -10. So one of my intercepts ends up being -10. And the other one, let's solve for that guy. Now here, 0 is in place of f of x, which is the same thing as y. So let's plug it in. Plug in 0 for y. And let's solve for x. Let's add 10 over to the other side. We're going to get 10 equals -2x. I'm going to divide both sides. I'm running out of room by -2. And 10 divided by -2 ends up being -5. And those would be your intercepts. So you don't always need the graph to find your intercepts. You could just take turns plugging in 0 for each and see what you get for those. So like, for example, even if the equation looks a little bit different, if I'm going to graph using intercepts, we start the same way. I'm going to start by finding both my y-intercept and my x-intercept. So let's do my y-intercept first. I'm going to start by plugging in 0 for x. And what we're going to do is we're going to solve for y. 4 times 0 ends up being 0. And my last step to solve for y is really just divide by -9. And 18 divided by -9 is -2. All right, and now let's solve for my other one. I'm going to take 0 and plug it in for f of x, which again is the same thing as y. So I'm going to have 4 times x minus 9 times 0 equals 18. And we solve. Now the nice thing is 9 times 0 ends up being 0. That's gone. And only thing I have left to do is divide both sides by 4. And it doesn't end up being the nicest, but you can write these as a decimal. In graphing world, you don't have to keep your answers as fractions. If I take 18 divided by 4, we get 4.5. And there are your 2 intercepts. Okay. So of course, we have to do at least one application problem. So first and foremost, let's talk about this guy. It says, example 3. It says a box of peanuts is poured into bags at a rate of 4 ounces per second. The table shows the function relating the weight of peanuts in the box to the time in seconds. So you're gonna even notice on this one, I don't actually physically know I don't know what the equation is, but I don't need the equation to find my intercepts. Again, to find my intercepts, I'm really looking for two specific things. I'm looking for an x to be 0 and a y to be 0. And I see those right now. When x is 0, y is 2,000. And when x is 500, y is 0. And those right there are your intercepts. This one I go left and right 0, up 2,000. This one is my y-intercept. This one I go right 5,000, up or down 0. I don't move off my x-axis, so that becomes my x-intercept. Now, that is your answer for part A. Your answers are going to be 0, 2,000, and 500, 0. Part B, though, because it's a word problem, that just means that we attach meaning to my x and my y. And let's actually think about what those are. So let's look at the y-intercept for fun. So for my y-intercept is going to be at 0, 2,000, right? So in those problems, let's look and see, well, what does x represent and what does y represent? Well, x represents time and y represents weight. So this really means when I say describe the meaning, it just means just give me a sentence. So for this one, if x is basically time, this guy right here is time, it says after 0 seconds. The y value, though, in this problem, the y value represents the weight. After 0 seconds, the bag, it says we're talking about a box of peanuts. So the box is 2,000. Weight is in ounces, it's 2,000 ounces. Okay, which kind of makes sense because when you start, you haven't actually poured any of those peanuts into the individual bags. But the x-intercept, though, is going to give you also some information. What does that one mean? Well, look at that ordered pair. That one's 500, 0. This one means just a little bit, it's after a certain amount of time has passed. After, oh my gosh, sorry guys. After 500 seconds, the box, hopefully you're thinking it is 0. It's not 0, it's empty. It weighs 0 ounces, which just means that the box is empty. So if I say attach meanings, all you're going to do is look and see, well, what do those columns represent? And then just give me your answer in a sentence. So what I want you guys to do is on example 4, I want you guys to pause your video and I want you to give example 4 a shot. So for example 4, hopefully this is what you got as your answer. Identifying hopefully is becoming the easy part. The y-intercept is the place where you cross the y-axis, and the x-intercept is the place where you cross the x-axis. So it's not just that the ordered pair is 4, 0, and 0, 200. Those do end up being your intercepts, but in this case, I said explain their meaning. In this case, if I look at this, this whole graph is talking about water drainage. Do we know what? No. Or where? No. But think about what we do know. We do know after 0, if I look at my y-intercept for just a minute, it just means after 0, the x, whatever x represents, our x-axis represents minutes. So at the beginning or at the end, we don't really know. It just means it takes about 4 minutes for all of the water to be drained from whatever this is. At the beginning, though, if I look at my y-intercept, this represents what's happening at the start. Here, no time has passed because I'm not moving right 0. I'm not moving right at all. So before we start actually draining whatever this is, maybe it's a tub, I don't know. But all I know is that there's about 200 gallons of water to be drained. So if that's the case, this looks more like a pool. Most people's bathtubs don't hold 200 gallons. But either way, though, the y-intercept represents at the start how much water there has to be drained, okay? Now, usually when it comes to graphing, that's why tables are not the only way to graph, though. Because what you can do is we can actually use the idea of intercepts to find just the 2 most specific points. So if you want to use graphing using just the intercepts, you can do that. My goal is simply just, if I'm going to graph using intercepts, I have to find my two intercepts. So let's find my y-intercept first. So I'm going to plug in 0 for x, and we are going to solve for y. And this one's actually pretty nice. 4 times 0 is just 0, and you have it right now. When x is 0, y is 4. So we could graph that. I'm going to go left to right 0, up 4. And now let's find my second one. I'm going to plug in 0 for y. 4 times x plus 0 for y. And let's see. Well, if I'm adding 0, this I can ignore. And to solve for x, my last step is just going to be to divide by 4. So my x-intercept is going to be at 1, 0. And you can connect your dots right now. We have everything we need to graph this line. So intercepts, that's kind of the nice part about it. Could you graph using a table and plug in as many values as you want? Sure. If you want to just find the y-intercepts though, this is also a really helpful tool. So again, I want you guys to pause your video and I want you guys to try example B on your own. All right, final answer is up. Your y-intercept, you should have had 0, -1. If you plug in 0 for x and solve for y, you should have got -1 for that answer. And then your x-intercept, if you plug in 0 for y and solve for x, you should have got 6 as your final answer, okay? Now, we are gonna go into more ways of graphing, but for today, you can really kind of choose. If you like using intercepts and just picking the two intercepts, you can do that. If you like doing what we did earlier and you like kind of making a table and graphing multiple points, that also works. I do not care which way you choose. I will let you guys know there is a third way to graph, and it's probably the way that all of you guys are thinking about. It involves something called y equals mx plus b, but we will get there a little bit later today. But for today, guys, that's it. If you have any questions, you guys know the drill. Reach out, email Miss Hardy, say hi, and we can set up a time to meet. Have a great day, guys.